Hi, my name is Mohit Srivastav. I am Senior Manager of Product Management at AWS, working on Amplify, AppSync, and Device Farm. In the next 30 minutes, I will give you a tour of Amplify with special emphasis on what's new, so you can see how Amplify might fit into your current and upcoming web and mobile app development projects. By all measures, users are spending considerable time online, especially in the past year as they accomplish more virtually. However, the competition for that mindshare is fierce. For native mobile apps, for example, 25% are abandoned after first use, and as a developer, you're competing with over 4 million apps globally. As the bar keeps on rising, front-end developers bear a significant share of this responsibility, with many responsibilities extending beyond the app front-end to the back-end as well. Some of these include supporting multiple platforms and form factors, creating differentiated experiences, getting security right, and making sure the data layer, or the layer between the app and the cloud, is solid. And that means efficient use of battery, efficient use of network, and being able to handle spotty network conditions. At the same time, developers are being asked to ship faster and iterate faster, and that includes even enabling non-developers to manage app content and app users. In a nutshell, those are the areas where we try to help with AWS Amplify. Amplify provides tools for front-end developers across the app lifecycle. During the develop phase, we help with configuring the backend and connecting your front end to that resulting backend. During develop, we provide a full stack experience for deploying your app front end and backend together, although you can deploy them separately. And after your app has been delivered, we provide capabilities for easily managing users and content, even by non-developers. An example of a customer who recently onboarded to Amplify was United Way. They built their Assist OC app within 3 weeks to help individuals facing hardship from COVID submit requests for financial assistance. And this was a full stack app development effort, front and back. Now let's walk into how Amplify might accelerate your app development efforts. So for the development phase, Amplify offers two key capabilities: the ability to configure your AWS backend quickly and per best practice for security and availability, as well as the ability to seamlessly connect front ends to that resulting backend. For configuring your backend fast, we've offered the Amplify CLI for a few years now, but today we're announcing an admin UI, which will be a big focus of this presentation in the upcoming minutes. And for connecting your front ends, we offer libraries and UI components. These tools work across 10 categories of common use cases for applications, such as authentication, data store, and storage. What's unique about all of these, so the programming interfaces, the UI components, the commands, is that they're oriented around the app use case instead of the underlying AWS service. That said, they are backed by the AWS service, so you certainly do have the option, for example, for when you're building out a GraphQL API, to go to the AppSync console, or when you're building out auth, to go to the Cognito console. But the programming experience offered by Amplify abstracts that one level higher. So launching at reInvent today is a new admin UI. It's a visual interface for configuring app backends in the Amplify way, if you will. If you're familiar with the Amplify CLI, the workflow is very similar. You start by modeling data and relationships, then you set up end-user authentication, and then after that, you can set up fine-grained authorization rules, for example, on storage or your records, in your database. New and unique to the admin UI is the ability to perform team collaboration even without an AWS account, And we've also brought this to the CLI. So you can invite users without AWS accounts, and they can contribute both to managing the content as well as configuring the backend, both in the admin UI or the CLI. All that said, the admin UI uses the same project structure as the CLI, so the two can be used interchangeably. The example I have here shows how to add a function or business logic from the CLI, even if you created the backend initially using the admin UI. And to streamline using the CLI, we've also improved the installation and launched a much lighter weight install that no longer requires Node on your machine. For the remainder of the talk now, we will walk through creating a field service application to highlight some of the new features we're shipping today. Let's start with the data model that must support two personas: the dispatcher, who creates appointments and work orders, and the field service agent, who acts on only their own appointments and work orders. Here's a screenshot of what a data model for that would look like. You can see here we have a type for appointments. An appointment can be associated with one or more work orders, for example, install TV or install voice. And a work order can have one of two states, open or closed, which is modeled as an enum. Once I've created my initial data model, I can continue evolving it in the admin UI, or I can pull it down to my local machine to work locally in my favorite editor. And that's the command that you see here by calling Amplify pull. Once I do Amplify pull, here's that same data model presented as text. Once you have this on your local machine, you can evolve it using text again. For example, I can change these auth rules, which currently are public, to be fine-grained auth rules instead. Also, once it's on my local machine, I can add additional capability, for example, functions or business logic or backend business logic for my application. And these are examples of certain categories that you may actually prefer to still develop on your local machine. You'd prefer to write your business logic in your favorite editor instead of a web UI, perhaps. Once you have your backend, Amplify provides libraries and UI components for connecting to that resulting backend. That said, you can use these libraries regardless of how you configured your backend, even if you have an existing AWS backend with DynamoDB or AppSync, for example. The unique thing about these libraries and UI components is they're deeply integrated with the frameworks. For example, for React, we offer higher order components for capabilities like auth. Also of note, we have launched preview versions of Amplify Flutter, and we'll be launching it as GA quite soon. So here's an example of what that means. So here's an example of using the auth component for React. I was able to take an existing application, simply surround it with Amplify Authenticator to add a sign-in and sign-up workflow, including UI, around my application. And then with just one additional line of text, I was able to add a sign-out button as well. As another example, let's look at Amplify DataStore, which provides an offline-first programming model for distributed data. Let's walk through a few use cases, including one we just launched support for. The first code snippet you see here is a basic save and retrieve example. What you'll notice is it's really no different than working with local data. I simply call a save operation or a query operation, and I pass it in a type, in this case, appointment. And I don't have to be concerned whether that appointment was created on my local, or in the cloud via another device. It's really the same programming model as working with local data, even though I'm accessing potentially distributed data. As another example, DataStore synchronizes under the cloud in real time. Likely you want to be aware of that so you can update your app UI, for example, a list view, accordingly. So that's what you see going on here. I can observe for changes to the underlying data store, which could have happened locally or via another device, via the cloud, and I can subscribe. And then finally, what we have here is a just launch capability, which allows you to sync just a subset of your data. So coming back to that field service agent use case, if I'm responsible for a certain region, let's say Eastern Washington, I synchronize all of the cases or appointments for other regions. And that's what this feature lets you do. And that allows you to make the most efficient use of your on-device storage. So here now is a deeper dive on the developer experience we showed earlier. The left shows you how you define your models and that they are ultimately persisted by a storage engine. But to the developer building the app, as we just saw, the only interface they have to work with is with high-level APIs, such as datastore.save, shown on the previous slide. Under the covers, it's the storage engine here that does the heavy lifting of persisting it to device storage, and also interfaces with the sync engine for doing sync with the cloud and other devices. And here's an expanded view of what's happening on the right. You can see here AppSync under the covers uses GraphQL resolvers that talk to DynamoDB that in turn work with two tables. And the two tables enable advanced use cases like conflict resolution. Let's say two devices made conflicting updates. These tables help reconciliate that. And also, let's say an app hasn't run for a few days and starts up again. The delta sync table ensures that only the updates that changed, only the changes that have happened since last time are synchronized to the device. And this helps make optimal use of the network as well as battery. Okay, with that, let's now dive into a demo of putting these concepts into action.
Let's get started. Here's a skeleton application for field service technicians. The application is not yet wired up to a backend. We want to add two core capabilities during this demo. The first is the ability for a field service agent to log in and see only their upcoming appointments. And second, because field service technicians are typically on site, they require the app to be fully functional when offline, syncing data with the cloud in real time when connectivity resumes. Let's start by choosing AWS Amplify in the AWS Management Console. From here, we select New App and Create App Backend. And let's give this app backend a name. Creating the app backend creates a new Amplify project, in this case field service, with a staging backend environment. You can also create additional backend environments, for example, for production or integration testing. Under the covers, a backend environment is a container or grouping of the backend capabilities, such as auth and data for your app. Each environment has an associated CloudFormation template that deploys the AWS resources required to provide those backend capabilities. Let's go ahead and launch the admin UI to start working on the backend. The first thing we will do is model our data. Let's create two types: appointment work order, and a relationship between the two. We can also define additional fields, such as a description on both types. And let's make description required. Once we've done that, we go ahead and click Save and Deploy. This will create an AppSync GraphQL API endpoint backed by DynamoDB and protected by an API key. Alternatively, you can switch the authorization mode to Cognito user pools for much finer-grained authorization at the user or group level. This includes restricting access to even individual records based on the app user's identity or group membership. Let's see how this is done. I went ahead and created a new owner field on the appointment type. You can now specify a rule that says that app users can only access the records where they are listed as an owner. In addition, let's specify a table level rule saying that anyone in the admin group can manipulate any record, even if they are not the owner. Now that we have built the app backend, let's connect to it from our app. We install the Amplify CLI using the new bundled installer, and then we pull the Amplify project to our local machine. This will allow us to both generate front-end code, such as models, for accessing the backend. It will also allow us to work on the app backend on our local machine, for example, to add functions as shown here. Now, let's take a look at the code we add to our app. We surround our app with the Amplify Authenticator component to sign up and sign in app users. We then add calls to DataStore, like this call to fetch appointments. Because Amplify DataStore supports real-time updates, we can also observe changes, whether they happen locally or in the cloud. And finally, to optimize the use of local storage, we can take advantage of the new selective sync feature. In this case, only syncing appointments in Washington. Now for the fun part. On the left, you see the admin UI again. This time, it's on the view for managing content. On the right side, you see the app. Let me go ahead and log in. Now in the admin UI, let's play the role of the field service scheduler, creating an appointment and a work order. We'll have the appointment take place in Seattle. We'll pick an owner other than myself. And let's also create a work order using that one-to-many relationship. Alright, I'm going to go ahead and hit save. As expected, the entry does not show up since I do not have permission. Now let's go ahead and change the owner to myself. Now the data is available to me, the field service agent, and updated in real time as you're about to see. Further, the data is available offline for when there is no internet connection. That is the power of Amplify Admin UI paired with Amplify DataStore.
In addition to the features from the demo, I now want to draw your attention to other new and upcoming functionality we built in response to customer feedback. First, we recently added support for Amplify DataStore in our most recent preview launch of Amplify Flutter. And what that enables, just as it does with Amplify JavaScript and React, is the ability to build applications with distributed data with the programming model of local data, like an offline first programming model. And you see here a data store example of querying data, except it's in Dart, unlike our prior example, which was in JavaScript. We expect to GA Amplify Flutter quite soon. The next capability I want to draw your attention to is Amplify CLI. And in a couple of releases, we added the ability to import existing resources. In the first release, we added the ability to import existing Cognito user pools and identity pools. And this enables two use cases. First, it enables you to authenticate end users using your existing Cognito resources. And then second, it enables you to authorize access to your resources using existing Cognito user pools. So for example, you can use existing groups and group membership to authorize access to resources that you create using Amplify. And then in the second wave, we added the ability to import existing S3 buckets as well as DynamoDB tables. And this enables you to authorize end-user access to these resources. In addition, it enables you to use these resources with other Amplify categories such as predictions. For example, to use an existing S3 bucket to provide inputs into recognition for doing image recognition. Finally, we recently added early support for container-based deployments, and these are meant to be an escape hatch for deploying websites or APIs using Fargate when you may have existing source code that runs on containers or just have a preference for using containers in certain use cases. And this provides two capabilities. First, it enables you to go from source code to fully running Fargate deployment in just a few steps. Amplify CLI sets up the underlying build and deploy pipeline for you automatically. Once you've done that, you can also use your containers with other Amplify categories such as auth. For example, we make it easy to put API gateway in front of an existing container-based API implementation and then use that in conjunction with auth for fine-grained authorization. Once you have developed your app, Amplify provides capabilities for delivering your app, both the app front-end as well as the app back-end. For the app front-end, Amplify provides static web hosting with two key capabilities. The first is around pointing Amplify to your existing static web app in source control on GitHub, for example, and Amplify will build and deploy that app for you automatically detecting which frameworks are used. And then the second capability of web hosting is managed web hosting itself. And this is a fully managed hosting service optimized for static web apps with features like easy custom domain setup, instant deploys, and URL rewriting. For the backend, as you've seen through this presentation, as well as in the demo, both the Amplify CLI and the admin UI generate infrastructure as code, which you can then deploy via the CLI or the console. You might be wondering, well, how do these two things relate? And they relate as follows. You can start with an existing static web app, for example, and as you start adding backend functionality using Amplify, for example, APIs, data, and auth, those capabilities in folder structure as your static web app, and then when you check into source control, Amplify will deploy both your front end and your back end in a coordinated fashion together. The front end going to manage web hosting, and the back end going to the underlying AWS resources like AppSync or Dynamo S3. That said, you certainly have the option to deploy the front end and back end separately. Once you've developed your app, now finally you need to manage your app that's out in production. And I touched on this just briefly in the demo, so I'm going to dive into a little bit deeper here. The first capability I showed is how you could manage app content from within the new admin UI. What I didn't show is that content editor also supports rich text editing using Markdown. So it's a quick and easy way for you to not just influence the content of the application, but the look and feel of the content in the application as well. Managing content, you can manage users and groups. So you can sign up users for example, in our field service case, you can sign up additional field service agents, and you can put them into different groups, which you can then use for authorization. For example, you might have a group of admins, you might have a region, and as you manage these groups, you can then use them for the fine-grained authorization in DataStore, but also things like S3. And then finally, with the admin UI, you can also give access to non-developer users, including those without an AWS. And that's because the admin UI is accessible outside the AWS console with its own URL. And when you hit that URL, you're prompted for username and password, and that doesn't have to be an AWS account. So with that, we will wrap up. To recap, Amplify provides tools across the development lifecycle that you can use together or separately. We hope you found this useful and look forward to seeing with the Amplify CLI and the admin UI for configuring backends, the libraries and UI components for connecting your front end, as well as the other tools like the CLI. Resources you can use to learn more: our website, our docs, our tutorials, our community site, GitHub, and Discord. What's notable about most of these resources is that the community has contributed significantly. And for that, we are very, very grateful. And I want to draw your attention to Discord in particular. If you're just getting started with Amplify, that's a great place to get started. You can interact with both Amplify team members as well as community members in a chat environment, and the chats are organized by topics. So, for example, based on platform, and it's a great place to get started. With that, thank you once again. I hope you found this useful and look forward to seeing what you build.